Welcome to another screencast, and today we're going to be looking at highlights from the June 17th, 2009 Regents Exam that happened between 1:15 and 4:15 p.m. only. But we're doing it at a different time because we're renegades. So right off the bat, looking at question number 1, they're talking about the expanding universe and what is the best piece of evidence in support of the expanding universe. Read through the question, and also this PDF. This screencast available as a PDF on Google Classroom as well for you to print out and go along with it as well. Since it's 2009 Regents Exam, the reference table has changed slightly and therefore might not match up with some of the answers. For example, there's a geologic history question in there that might not match up with the current geologic history that's in the Earth Science reference table. Redshift. Remember, redshift, it's going to a longer wavelength. The wavelengths are expanding because the universe is expanding. Remember, the greater the redshift, the faster the galaxy is moving away. And most objects in the universe exhibit a redshift because the universe is expanding. But what is it expanding into? Ooh. So, which object forms by the contraction of a large sphere of gases causing nuclear fusion of lighter elements into heavy elements? Comes up quite often, nuclear fusion for a star. So our sun is currently doing that right now. 600 million tons every second of hydrogen and helium. Pretty impressive. Comes up quite often, altitude of Polaris is equal to your latitude. So in this particular case, this particular observer would be located at 52 degrees north. You cannot see Polaris from the South Pole, so that's why it's 52 degrees north. Which statement best describes the position of the sun at sunrise and sunset, as seen, a lot of S's there, by an observer in New York State on June 21st? Well, this requires a little bit of a review over here. So if we take a look at our page 4 of the Earth Science reference table, they have the lines of latitude marked out for you right over there. Tropic of Cancer, Equator, Tropic of Capricorn. It's very nice of them to do that. There are certain dates that should stick out for you. So June 21st, the sun's rays would appear to be directly overhead of the Tropic of Cancer at solar noon. March 21st, September 21st is the equator, and December 21st is the Tropic of Capricorn. So if we kind of look at this map and we just say, okay, well, this right over here would be exactly east. This would be north of east. This would be south of east. And if we kind of go back to the question, oh, and there we are, New York. Right there, through some digital wizardry, we're able to put New York there. Pretty exciting times we're living in. And if we just take a moment to go back to the original question, which statement best describes the position of the sun at sunrise and sunset? So, again, we look for June 21st. It would appear to rise north of east. Never get to be directly overhead at the zenith, but it would be the highest angle of installation of the year for New York State, and then set north of west. So, answer to that question, the sun rises north of due east and sets north of due west. This is a great question over here. So they give you a set of a bunch of planets, and then they give you a characteristic of it, and it's asking you which characteristic is represented by X. So you look at the numbers there. The numbers should be somewhat of a familiar value, and if you compare that to the solar system data table on page 15 of the Earth Science reference table, and now we match up that question with this through some digital wizardry, and we can take a look at it and see that, well, the planet characteristic, which one matches up the best with those particular numbers or those particular values, and we could see it relates to the eccentricity of orbit. This question 10 is a great question. Let me just kind of expand there we go, the viewing surface of this. Now I really did it, didn't I? The diagram below shows a laboratory setup. Very exciting, the word laboratory. The rubber band holds filter paper across the base of the open tube to hold the soil sample. The tube is placed in water as shown. The upward movement, remember that's called capillarity, is represented by arrows. It's when water goes against the force of gravity. The height of the water that moved upward within the soil was measured. Students, sounds like a dream come true for you guys, repeated this procedure using soils with different particle sizes. Results of the experiment are shown in the data table. So if you're taking a look at this, and I kind of have to shift the viewing screen, sorry about that, that way so you can see all the choices, and you can see the arrow or arrows, represent the upward movement of water against the force of gravity or capillarity. And over here, you can see that it's showing you the particle size of 0.006, of 0.2, 1.0, and the height. So it seems to be the smaller the particles, the higher the column of water, which is exactly what we've been talking about. And so if we go to the next page, we can see that capillarity is greater in soils with smaller particles. Now notice that they have a thing about permeability there. And if you look at choice 3, permeability is greater in soils with larger particles. That's absolutely true. That's a true statement, but it doesn't answer the question as to why the water would rise higher in the smaller particle than in the larger particle. Ready for some more fun? Question 11. When two tectonic plates collide, oceanic crust usually subducts beneath continental crust because oceanic crust is primarily composed of igneous rock that has... So this is kind of a multi-step question. If you take a look at the inferred properties of Earth's interior, you can see that bingo right over there is oceanic crust, basalt, and the density is 3.0 grams per centimeter cubed, as compared to continental crust of 2.7, right? So, and then if we find basalt over here, we could see that it's mafic. So now when we match it back up with this question, what is really the best answer for this? That's correct, high density and is mafic. New York State's generalized landscape regions are identified primarily in the base of elevation and... Now again, you look at these two pages together. So these are the landscape regions. This is the generalized bedrock geology of New York State, which you all probably memorized at this point. And it is not only the elevation, but also the bedrock structure. Diagram below shows an outcrop, this is question 17, of different layers of sandstone in a region receiving heavy rainfall. Which sandstone layer appears to be, and it's very important that you know, the least resistant to weathering? Least resistant means it weathers the most. That would be, you guessed it, nice use of color there, right? Purple and green. Not bad. 18. Which process led to the formation of thick salt deposits found in the bedrock at some locations in New York State? Well, you definitely have to think about this one. You think salt deposits, and you have to think, okay, well, it's not igneous, it's not metamorphic. It would be sedimentary rocks. And if you take a look at the sedimentary rocks, rock salt, and if you look at the comments, crystals from chemical precipitates and evaporates, in case you don't know what I'm talking about, just did that with my mind. And then you can go back to this one and just see what would be the best answer, or the only answer that actually makes sense would be evaporation. All reference table there. Kind of cool, right? This comes up quite often, I must say. The gases in Earth's early atmosphere are inferred to have come primarily from, and this is just one of the things you just have to know, volcanic eruptions, and they will sometimes call it outgassing. Outgassing of Earth's interior, which is a volcanic eruption. Which characteristic would most likely remain constant when a limestone cobble is subjected to extensive abrasion? Abrasion is a physical process, so the thing that would remain the same wouldn't be the shape, would not be the mass, would not be the volume, but the composition. This one, according to the fossil record, which sequence correctly represents the evolution of life on Earth? Well, if you look at the pages 8 and 9 on the Earth Science reference table, and you look at life on Earth, so we're really primarily just looking at page 8, and you can see there are soft-bodied organisms. Then the next thing we have is abundant fish. Then we have abundant amphibians, and then we have earliest mammals. Now if we take this information, we go back to the original question, we can see that the answer there is question 4. So it can be overwhelming sometimes, but just try to keep your wits about you to look at the reference table. And don't forget, you can write on everything on your exam, everything including the reference table. Data table below compares climates of 2 United States cities located approximately 43 degrees north latitude. That's very important. It's based on a 30-year period. Very important. All right. So if you take a 43 degrees north latitude, which statement best explains the climate variation between these two cities? So, City A and City B are located at the same longitude. City A is located at a high elevation, and City B is located at sea level. Well, maybe, possibly, I doubt it, but City A is because it was at a high altitude, or high elevation, Would city A have this high of a temperature? Likely not. City A is located far inland and city B is located near a large body of water. Well, what would happen if that were the case? You'd have a large temperature range. You would also have more precipitation at the city that's located near a large body of water. That looks like a pretty good candidate. City A is located on the East Coast and City B is located on the West Coast. That doesn't really make much sense. So, closer to a large body of water, smaller temperature range, and generally a higher precipitation pattern, which would be the exact thing you're seeing over here. City B has a smaller temperature range, and it also has much more annual precipitation. Snowfall counts as precipitation too, by the way. Alright. Table below shows some properties of 4 different minerals. How exciting. And you look at all the compositions, and now if we keep our wits about ourselves while we're on the Earth Science Regents Exam, and we know to turn to the last page, which you really don't have to turn, I guess, flip to the last page. And if you look at the various minerals that are indicated here, and again, right on your reference table, who cares, all right? You're going to see that these are your choices: magnetite, olivine, quartz, and garnet. You can see that where they line up, where they're found on the Earth Science reference table. And then if we revisit that question, take a look at it, we could see SiO2 is the composition. And if we go back and look, oh, which one would that match up with? It would match up with quartz. Adjacent water and land masses are heated by the morning sun on a clear, calm day. After a few hours, so it's not just after sunrise. Surface wind develops. Which map best represents this wind's direction? Well, what heats up faster? Land, because land has a low specific heat. Then, therefore, the temperature of the land is going to be hotter. That air is going to then rise. It's going to be low pressure, rise. What's going to come in to replace it? The high pressure. Where's the high pressure from? From the cooler air located over the water. Remember, warm air rises, therefore it's low pressure. Cold air sinks, therefore it's high pressure. So what's going to wind up happening is we're going to get a sea breeze, where the wind is coming from the water and blowing towards the land. At night it reverses. The land cools off faster because it has a lower specific heat. And then the temperature over the land gets to be cooler or higher pressure. The air over the water is warmer and is a lower pressure, and that air starts to rise. The high pressure from the land comes in to take the place of the low pressure air that rose over over the water, and therefore we get a land breeze at night. This is a pretty complicated question. If you look, it has ISO lines, in this case isobars, it has weather stations, it has fronts, it has a mid-latitude cyclone, and it has an outline of the United States. Hopefully near the United States part. But anyway, so you can see which station model correctly represents the barometric pressure at station A. Barometric pressure, also known as air pressure, also known as atmospheric pressure. And you can see here, the isobar over here is 1016, and the one over here is 1020. It's pretty close to, it's closer to 116, so you probably looking at 1000, I said 1016, I said 116, I meant 1016. It's probably closer to 1017 in terms of air pressure. And if you forget, look at the Rosetta Stone on the key to weather map symbols in the Earth Science reference table. And you can find, well, here's my example. I have 196 on my station model. Looking at the Rosetta Stone, that's tantamount to 1019.6 millibars. So how many numbers do I have on my station model? Well, I only have 3. And therefore, if I look back at this question, let's just look at the various choices. 150 would be 1015.0. 170 would be 1017.0. That's pretty logical. But 115 would be over here. 1017 would be over here. So it looks like this would be the right candidate. These two are both wrong because not only do they have more than 3 numbers, but they also have labels there of MB for millibars, which is not the proper thing to do. So that is the correct choice. What is the approximate rate of Earth's revolution around the Sun? So rate of rotation on its axis is 15 degrees per hour. Rate of revolution around the Sun, it takes it 365 days to go 360 degrees. So it's about, and that's why it says approximate. It's about a degree per day. Which event is caused by Earth's revolution? So rotation we know is Foucault pendulum. Rotation is also Coriolis effect. Rotation is rising and setting sun, rising and setting stars, rising and setting planets, rising and setting moon, right? But what about revolution? So the first two are talking about evidence of rotation. The Foucault pendulum, deflection of planetary winds, that's all for rotation. Apparent rising and setting of sun is also rotation. Different constellations observed in the night sky throughout the year. And that's evidence of revolution. Remember that fun stuff? I'm sure you do. We're getting towards the end here. It's a pretty long screencast. Sorry about that. Question 43. Which statement best explains why location A has a cooler climate than location B? Well, they're both coastal. They both seem to be at about the same latitude, so that wouldn't have any impact on it at all. So let's take a look at our Earth Science reference table, shall we? Let me take a look at surface ocean currents on page 4, and if we could estimate where location A is and location B, using some digital wizardry, and we can see that location A seems to be affected by this Labrador current, where location B seems to be influenced by the North Atlantic current. It seems to be pretty interesting. So if we take a look at the choices, location A has a longer duration of insolation each day. Well, they're at the same latitude, so duration of insolation and intensity of insolation is probably samesies. So location A is influenced by a cold ocean current. That sounds logical. It's the Labrador current. Location B is farther from the equator. No. Location B has less intense insolation. Well, same latitude, same intensity of insolation, same duration of insolation, so none of those are correct. The logical choice is A is influenced by a cold ocean current. So these are just some of the highlights from the June 2009 Earth Science Regents Exam. Pretty much the last screencast done of 2016. And pretty complicated stuff you're doing, but not as complicated as your first job interview, which might look something like this. That'd be pretty challenging, right? I wonder what's going on in space, in particular outer space. Very exciting times we're living in.